of the people. Uh, okay, so the person that so the first author, he was and he still is. He's a paleontologist. He got his PhD from Virginia Tech, and he worked at postdoc at Harvard. So he is like say coming from the geology biology background. And then another person that plays a key role and who is going to give a talk is Annie Roof. So he got his PhD working with, I think, with Peter Fox. So Peter Fox is the second last person in the first row. So at the it's a Rensselaer Polytech Institute, or people call it RPI. So now the second author or the speaker on Wednesday, he's working at the Carnegie Institution of Science. So he's a data scientist to begin with. And unfortunately, Peter Fox, the advisor, died, I think, in late 2020, slightly more than 1 year ago. And he also had a bit, because one of our collaborators, Huang Fang, he was working at RPI before working at Peter Fox. So it was unfortunate that Peter Fox died at a relatively young age of 61. I mean, he's not that young, but he's still relatively young. It's a big loss in the community, and the institution that he has been being a director at the RPI has really made a lot of contributions for pushing for the geoinformatics in the earth science community. So for this paper is basically one of their results or combinations with the paleontology community. So yeah, Angelique, please go ahead.
Okay. Thank you, Professor Zhang, for a brief introduction of the authors. And today I'm going to introduce the paper as 2018, Quantifying Ecological Impacts of Mass Extinctions with Network Analysis of Fossil Communities. I don't have a strong geology background, so I read the paper with difficulty, and I may not understand the terms well. So apologies if I have misunderstand anything. From the paper, I know that the motivation of this research is that efforts to compare biotic crisis of the past and present. However, encounter difficulty because taxonomic and ecological changes are decoupled. So this paper wants to combine taxonomic and ecological change together to quantify the ecological impacts of extinction events over geological time. So one of the most important data structure is graph, and there are three main concepts.
Yeah, okay. I could add one word. Although I'm not a paleontologist, but from my understanding that I'm trying to combine two things together. So here the taxonomy, to me, that is more like say how the fossils looks like, because they are the paleontologists, they look at the fossils just like we are looking at the rocks. And so that's what has been preserved. So that's the result, that like they are the survivals of the in the past. But there are many plants and animals, but I should emphasize that here they are not talking about the microbes here. So for the plants, animals that survive as fossils with the geological record, on the other hand, that the people should look for the other environmental parameters. For example, what's the temperature? What's the, for example, what is the, let's say, annual precipitation, how much rain we get per year. For example, that's all very important environmental factors. Or are there any volcanic eruptions? Or what is the sulfur content in the atmosphere? What is carbon dioxide content in the atmosphere? So all of these are important environmental parameters that should be highly associated with the animals who are plans that prospered or died or preserved, but they were being treated not at the same time as much as what the people should do. So this work basically they try to combine all the related parameters together. So then they're trying to use this network analysis to build more connections. Actually, I'm not a paleontologist, but that's my understanding of the rationale of what they are working on. So
Okay.
Andrew, go ahead.
Oh, thank you, Professor John. And one of the things that I am curious is that this paper does not include many ecological parameters like Professor Zhang said. I don't find any ecological factors like temperature or pressure or something like this. So let's get into the detail of the paper. And the main, I think the main contribution of this paper is to construct a graph, several graphs. And the graph has three main concepts: node, edge, and weight. And so the meaning of the node here in this paper is the taxa, which means a taxonic group of any rank, such as a species, family, or class. And edge is in this paper means that the co-occurrence at any fossil collection sampling point. And I'm not very clear about this phrase fossil collection sampling point of Paleozoic age. And the weight will be the co-occurrence accounts in PBDB database. And actually, the author construct 5 graphs named O, F, G1, G2, G3, and which means O for order, and F for family, G for genus. And this is the basic information of this graph listed here, like nodes, unique links, and geological age range, node rank, as I have talked before, and text included. And so the G2 only contains marine animals reported in reef phases, and the G3 only contains reef building animal taxa. That's the basic information, and the author also lists the diameter and mean distance, density, and the transitivity. These are all global measurements of a graph, describing a graph. So the PBDB database is the data source of this paper. And as you can see from the top pictures, and users have an interactive map, and each node represents I think this fossil collection sampling point, and the color means the corresponding geological time. And after you clicked on certain points, you can get this left picture of detailed information of this fossil collection, and you will get the collection number and occurrence, stuff like this. And after clicking this collection number, it will show you which of the how many of the like animal these species distribute in the taxonomic perspective. And so I'm going to directly to the methods of network analysis. So the actually the author has mentioned in paper that it used several methods, but modularity-based analysis wins out. So modularity is a measure of the structure of networks of graphs, which measures the strength of division of a network into modules, also called groups, clusters, and communities. These are all equivalent words. describing the small communities in a large graph. And the intuition of this metric is to maximum the connectivity in certain community and minimize the connectivity between communities, between different communities. So these are the formulas, and actually it's a obvious and easy metrics, and it actually has a basic assumption that the edge distribution of random chance is not regarded as a meaningful community structure. So based on this, A means the edge weight. It is 0 or 1 if you're undirected graph, for a weighted graph, and the actual weight. And minus this, I like to say this is a random distribution graph basis. So minus this will get the expected number of edges between vertex I and G if edges are placed at random. So after minus this random distribution graph background, and you will get the actual meaningful community structure measurement. And that's and then summing over all those edges, and you will get the modularity score. And the actual test this paper does is that it does the community detection test for network analysis. So it actually is like unsupervised clustering, like k-means. You can just do a simple analogy to k-means. So if you input a graph structure and you don't have any labels, and you also don't need to provide the number of clusterings, and this low vein algorithm will get you each node a label and indicating which communities it belongs to. So I'm going to briefly introduction this Louvain algorithm. So it has basically two parts. The first part is that it will for each node I, the change in modularity is calculated for removing I from its own community and moving it to the community of its neighbor J of I. And then estimate the delta Q. Once this value is calculated for all community I is connected to, I is placed into the community that results in the greatest modularity increase, which is greatest delta Q. And this process is applied repeatedly and sequentially to all nodes until no modularity increase can occur. And as the diagram shows, the first row means the part 1, and the second row means the part 2. And simple, just like aggregate all the nodes in that belongs to the same community, and you will get E. Sorry. And each, you will get a rather large edge weight, and you will get also this is self loop, and it can do a second round of compress is optional for you also using this delta Q as an object, and then just recover this F to the A, and you will get the label assigned to each node. Okay, so that's all for the algorithm introduction. And then I'm going to show some of the visualization of this graph, and you can see the color of the nodes means the different communities assigned by a previous Lovan algorithm. So the first is like O, graph network O, and the second is network F. And you may be more familiar and sensitive to these words, ME. And these are labeled as geological time, I suppose. And these are three Janus graphs and visualization. And it also choose a graph with modularity larger than 0.3. So some of the nodes in the graph may not have a label, just like DB scan, I think. And then it comes to the result analysis part. The author has produced a very excellent graph, like which is in the middle, and it also produced two kinds of time series plot. But I'm not really understand the meaning of the Y label. Maybe we can talk about it later. So it draws three main conclusions. The first is community turnover occurred largely during mass extinction radiations, when ecological reorganization resulted in the decline of one association and the rise of the another. And the second is identify 5 evolutionary paleo communities at the generic and the familial levels, in addition to 3 ordinal associations that correspond to Spekowski's Cambrian, Paleozoic, modern evolutionary funnels. In this context, we quantify magnitudes of ecological change by measuring shifts in the representation of evolutionary paleo communities over geological time. So the second conclusion means that the results and the network classification result is to some extent correspond to previous scholars work, as this Sepkotis work. And the final conclusion is the Great Ordovician biodiversification event had the largest effect on ecology, followed in descending order by the Permian Triassic, Cretaceous Paleogene, Devonian, and Triassic Jurassic mass extinctions. Despite its taxonomic severity, the Ordovician extinction did not strongly affect a co-occurrence data of taxa, affirming its limited ecological impact. And I think this conclusion comes from the left top. Ordovician is not that large as the simple taxonomic result. It only draws only several compared to the other time, geological time. And that's all for my introduction for the paper.
Okay, thank you. So any questions from our group members, our participants?
Maybe let's discuss these graphs because I didn't understand fully the Y. No, the slide that was on right now, the last one, where you said you don't
10.
know the Y.
10.
Huh?
Is that the slide 10?
Yeah,
Slide
yeah,
10.
yeah. Mm-hmm.
slide 10, number 10.
Yeah, so
of
the
your
total diversity minus singletons, what does it mean exactly? I'm
I
not
don't
quite
know.
sure.
slide 10.
Yeah, so so I'm asking everybody whether someone can tell.
Is that
Also
slide
just
10?
write the original words in their paper.
Could you turn to that picture? Is that this figure?
Yeah, this figure.
Yes, this one. Mhm.
Never network. Is that okay? Total diversity minus. So Ben typed in the chat a family taxa reserves more impact tree methods that distinction. What do they want to say here? So they have an index for total diversity. So that I could understand. So what is in that figure, Tasu? Then is it possible for you to open your mic? And Ben, is it open or possible for you to open your mic? I don't know which page are you referring to.
I think
Like this slide.
he's talking about the lowest picture on the 10th slide, where you see there's a blue line, total network or family network, which is yeah.
Okay. So so go ahead, Natasha. Go ahead.
No, I'm just talking that as far as I understood, he was talking about this picture, the lowest one in this slide, and that the family taxa, family network model shows most total swing. And he was asking, did he understood it correctly, or is there some explanation for that?
Okay. Actually, I don't know. I'm not a paleontologist. I don't know, but I try to interpret what they're trying to say.
So as far as I can tell, these indicators has nothing to do with network analysis.
But this figure does not come from the network analysis result. But does the
Yeah.
figure? But does the figure? Okay, this figure doesn't. But for the figure below, in the same slide, does that figure come from the network analysis?
I don't think so too. The network analysis only gives the different lines, color different lines. It just give label to each node.
Just give label to what?
To each node in network.
Okay.
No, a node means taxa. Yeah. So these indicators is invented by the author. I don't know. But most of the conclusion and meaningful conclusion comes from this time series plot.
That must be what they are trying to say. But that must be come from the network analysis. Otherwise, why they are doing network analysis?
They want to classify each node, each taxa.
So?
But module means the group or class.
So they could classify each taxa. And so what? so that they could get different types of different number of groups. Is that what they're trying to plot?
And I think they give each group a name, like a name classified by geological time. The different color means different group.
Okay. So Tuhin suggests that maybe Nidiker responds to that during the Ordovician extinction, although the total number decreases, but the number of text or species remain the same or may have increased. So that means they so the diversity doesn't decrease. So the diversity kept during the extinction. If I could interpret Tuhin's interpretation right. But is that the case? But in my interpretation, that mass extinction is that when most of species were wiped out, right?
Mm-hmm.
Okay, I have a relevant question for you, Andre. So for this, compare with the Nanjing University 2020 paper published in Science. So did they use the published data in terms of the horizontal axis for the time, the geochronology? Did they, in this paper, did they use that information?
Yeah, the Nanjing University used what?
So in this paper, you see the slide you are showing now, horizontal axis, the x-axis is time, right? The geology time from, let's say, 540 million years to now. And I recall at the Nanjing University's work, they were talking about the time between maybe 500 million years to, like say, 300 million years. And then they provide a very high time resolution in their work. So, okay, so this paper basically is published before Nanjing University work. Okay, so this PNAS Proceedings National Academy of Sciences for this paper we're reading was published in 2018. Okay, so actually they were before that. But my feeling, I don't know whether I'm right, is that the paleontologists always talk about these 5 large mass extinctions. And what's new they are coming out of it? That's this one that, so what's new coming from this 5 mass extinction? I still didn't get it, actually. So what's the new understanding that people got from the 5 mass extinctions that people didn't got it before?
Yeah,
by network
that's
analysis.
a good question.
Or this, so it's just quantifying the magnitudes. So if they quantify the magnitudes, okay. So basically, if that is right, that could I say this, that if you like the figure in this slide, the lower one, so does that mean the Great Ordovician mass extinction, not a mass extinction. So basically, the higher index it is, the higher diversity it is. Yeah, by that, then total swing, what does it mean? So why call it total swing other than total diversity? Because to me, it's like total diversity makes more sense.
Anyone who has background knowledge and can explain these two
Oh yeah,
y-axis?
actually, Zhao Wenyu probably know more paleontology than anyone of us in this room now. Zhao Wenyu, could you say something? Maybe you are still working at a company.
Sorry, I don't know them either. But I had a look at like the caption of the figure, like figure
Yeah,
2.
yeah, caption.
So
You want to know what?
so
This one.
it says plots show diversity versus geological age. So I think minus singletons, diversity minus singletons maybe just another way to show diversity. Maybe they just wanted to like to make the plot like look better.
What is singletons?
I don't know. Sorry.
And the total swing caption. Swing. You mean that it can just be regarded as diversity?
Yeah, I just learned that from the caption.
Yeah.
I tried to Google it and try to see what does this singletons mean. But this looks like more like a genomics definition. I don't know how is that related to what they're trying to say. Okay. Yeah. Ben posed another question. Is the network network analysis itself is machine learning?
These network analysis only utilize the structure of the graph. It does not utilize the other features of the nodes. So I don't think it's a machine learning algorithm. A math explanation, and as you can see from the metric, it's quite intuitive. It's better than machine learning algorithm, although there are some graph machine learning algorithms that can do the same thing, which is community detection. Must be something well. So is my answer your question? So Turing has said the singleton must be something well established, which he means it may be a term of paleontology, right? Yes, it must be a term that we all don't understand.
That's what we think. But Wenyu doesn't think so.
Okay. Actually, I also don't really not understand the data from PBDB, and I don't. Yeah. That's some detailed questions that we can talk about later. We can discuss later. And
Okay. So, okay. I hope that the speaker, actually it's interesting because the speaker on Wednesday, he's not a paleontologist neither. So he's a data scientist. So his talk, I think he will talk several applications of the data sciences working with in different fields. So one field is in paleontology, another field is in mineralogy. So so let's see what is going to speak about. But I'm curious whether he could explain this well. So Andrew, actually, I think Ben asked a good question. So he's asking whether natural language processing is involved in the data processing, because I know that the very first time that this large-scale database was built was by Peter Shannon at the University of Wisconsin back then. Then they work at Stanford University. So it was Ce Zhang, who is currently at the ETH, but was a PhD student at Stanford back then, did a work called the deep dive. And so Ce Zhang also gave a talk in our webinar before. And so at that time, they were mainly that all they do was mainly natural language processing because there were not names. And then they try to count the frequency of different type of fossils occur in different stratigraphies. So they counted for several millions of publications. So I don't know, Andrew, does in this network analysis requires natural language processing?
I think the PBDB database has does some cleansing or standardization process before loading the data into database. So I don't think it's necessary since I think all the names are consistent with each other. And the paper does not mention the information of application of NLP. But if you are trying to extract data from raw PDF, and that must need NLP tech. So I think from PBDB, which the source of this paper, I don't think NLP is required.
Okay, I hope. Let's see what the speaker is going to say about. I think it's great. Thank you very much, Andrew, for leading the paper so that we could get a little bit understanding of this paper better than I read it by myself. Okay, so how's everybody going? So Natasha, how are you doing now?
I'm fine. And how are you? Is there anything new?
Our holidays is coming to an end. So this week everybody goes back to work because Lunar New Year was about 2 weeks ago. So yeah, so it get busy on the street because in the city that we are live, Hangzhou, I don't know, maybe half of the people are not from here, or even more. So they just went to their hometown for the Lunar New Year. So it was not completely empty, but it was no traffic for at least 2 weeks in the city. So yeah, so it becomes busy now. So this week is pretty the time people all getting back to work. So
Sorry for that. Sorry to hear that. I've always hoping that holidays will last forever. So
yeah. But I think it's okay. I mean, yeah, my family's they visit me, so it's okay. So Zhao Wenyu, how's your life in Shanghai going? So did you visit your hometown in Northeast China, or did you stay in Shanghai for your Lunar New Year?
I have been working for a week, I think, and still busy. I think nothing new.
So did you went back home? Did you went back to your home during the Lunar New Year?
Yeah.
Okay, that's good. So you did home for 1 week. Okay, that's good. Okay, so Hassan, Sunny, how are you doing? So, were you got stuck in Shenzhen when you spent your Lunar New Year?
Nope, I'm just staying in my hometown because but tomorrow morning I will just go back to my campus. And recently I'm just passed on the program I applied, and now I'm preparing for the thesis of the graduation.
Okay, that's good. So to him, any new update? New Omicron?
No, nothing new. I have been around. We went to beach last week, so that's it. That's pretty much it.
Okay. So, thanks everyone for your participation. And this Wednesday, the speaker will give a talk, and also this Wednesday, Ben Lei Yang as well as Chen Tao will fly to Guangzhou, Guangdong province. So they will meet at the southern part of China and went to the Institute of Geochemistry at the Chinese Academy of Sciences there. So they're going to perform a little bit lab work, maybe for a couple of weeks. So they're also going to enjoy some Cantonese food. That's good. I will probably go there at the end of the month or early next month. So, but our paper reading will still continue online. So that's where we're now. Okay, it's great. It's great to see everyone here, and thank you again, Andrew, for the discussion. And I forgot to ask, how are you, Andrew? So how did you spend your leave?
I've been back to Winchi town. And yeah, it's quite easy. And now I'm also preparing my previous research and also pushing forward to chemistry pi.
Okay. So for your Lunar New Year, did you do the fireworks?
No, I think Hangzhou does not that does not allow the fireworks. And I also did not heard any sound of fireworks.
Okay. So probably we live in different parts. I heard people did that. I know it's illegal, but I saw people play fireworks here.
Oh, that's cool.
Yeah. Next time, people should show some pictures of Guangzhou. People will have very high temperature there. It's best time in Guangzhou. So temperature is normal. In April, it's very hot. It's beginning to become hot in Guangzhou. So
you can meet Sunny there.
Yeah. I don't know. Because Sunny will travel. Let's say travel past Guangzhou, by the way,
Oh.
arrived at university in Zhuhai campus, next to Macau. Okay,
Oh.
okay, that's all about it. Good evening, everyone. Maybe good afternoon, and if your time zones the afternoon. So, great. Then we will see the speaker on Wednesday. If not, watching the videos to see how the speaker talks about it. Okay, thanks again, Andrew, and thanks everyone. Bye-bye.
Bye.